chemistry, chemical bonding. So I'm going to start, guys, now. Chemical bonding, how these chemical bonds are there. This is only for the reflection for this class, right? So here there is two dots are there. What do you mean by this dot? Can anyone say me what is this by dot? Actually, these are Lewis dot, right? Lewis dot. We will be seeing what is this Lewis dot means, right? We will be seeing in the in today's class, right? So resonating structure. One thing I just wanted to tell you about the resonating structure. What is the meaning of this resonating structure? Resonating means what? Do you have any idea? DRT, you have joined after so many classes. Where were you? And Buana, please turn on your camera. Pranav, please turn on your camera. Where were you, DRT?
Sir, I have exams, sir, so only I didn't attend the classes.
Yes. You are having exam.
Yes, sir.
Okay, okay. Try to not miss the class because exam will be, there will be at least 3 to 4 examinations will be there of 6 to 7 days each, right? So if you will be missing that, so 42 classes you will be missing in a year. If 42 classes, calculate that. It's your part only. If you are missing 42 classes, then how much money that you are wasting, that you have deposited it to TZ campus, and you are not taking this class 42 classes in a year, then how much money you are wasting? So it's your part. It should be calculated, right? Okay, now come to the point. So guys, yes, so resonating means what? Let's suppose in the case of benzene, let's suppose I'm taking, this is the structure of benzene, right? You might have gone through this structure in your 10th standard, right? You might have gone through this structure. Yes or no? Please tell me. Just a minute, guys. Right? You might have gone with this kind of structure in your 10th standard, right? This is what? This is nothing. This is benzene only, right? So benzene is having what? At alternate position, you can see if this is carbon 1, right? Carbon 1, this is C2. This is what? C3. This is what? C4. This is what? C5, right? This is what? C6. So at the alternate position, double bond is there. C1. So C1. So you can take from here single, double, single, double, single, double. So we can say that this is a resonating structure, right? Here also you can see here minus, single bond, then again double bond, then again what? Single bond. So if this type of structure is coming, it means this is resonating structure. See here, double bond, then what is this? This is lone pair, and again single bond, and again lone pair is coming. It means it is a resonating structure. Getting my point? If lone pair, single bond, and after that, if let's suppose double bond is coming, and it means that what is this? This is also a resonating structure. If double bond, if lone pair minus, then again double bond is coming, then again single bond is coming, then again lone pair is coming. It means this is what? This is what? This is nothing. This is resonating structure. Getting my point? Is it fine for you? Okay. Now this is only for the recall purposes, guys. You might have gone through this in your previous classes about the periodic classification of elements, in which you might have learned about the S block, P block, D block, F block, everything we have seen in our previous classes. Yes or no, guys? Please tell me. This is what? This is S block. This is only for the remembrance purposes only I have given here. S block, right? This is what? D block. This is what? P block. And this is what? F block, right? Fine, everyone? This is nothing. This is what? F block. Clear? Any problem? No. Okay. So now you can see here, there is a bond. Here you can see double bond. Here you can see single bond. Even this is also having single bond, right? This you can see single bond, double bond. So this is the just for the introduction part only. We can see here there is a bonding, right? Getting my point? This is what bonding. We can see here bonding. Yes. Okay. Now we will be seeing about the octet rule, and we will be also seeing about why do atoms combine? Why do atoms combine? Do you think why there is a combination? Why do atoms combine? Why there is a need of combination? Why they are not alone to get the stability? Even in our even in our daily life also, you know, now you are learning. Now you are in your like school days. After that you will be going in college. After that you will be going into what? Job phase. Like someone will be working in Google, someone will be working in Microsoft, someone will go for doctor, MBBS, MD. They will be doing like that, right? Bhuvana Sri, the famous doctor of India. Yes, if you will go to her, so he will be treating you. Yes, oh, you were my friend. Yes, come here. See, yes, you are suffering from this disease, so you need this medicine. Go and be chilled, right? So like that. So Maurice will be going to sorry, Anil Dev will learn about the physics, astrophysics, and he will be telling you about that. So that there will be there, right? So there's also need some, you know, there's a reason behind that. So why do atoms combine? So what I was saying, after that phase, after your job phase, there will be a phase of what? Marriage, right? There is a phase of what? Bonding. So why do we do this? To make ourselves stable? What our father and mother says. Yes, after your marriage you will be stable there. So here also, you in chemistry also, if you will be going to see, to get the stability, there is a need of combination. Why there is a need of combination? To get the stability. Getting my point? Now come here and see the points. Tendency to acquire noble gas configuration or octet rule. Why do atoms combine? And you know well that what is the noble gas configuration? That is a stable configuration. Yes or no, guys? Please tell me. Noble gas configuration means what? There is a stable configuration. Now, come to the second point. Tendency to acquire minimum energy and stability. Getting my point? See, guys, when you will be in your stable case, when you will be in stable phase, it means there is a minimum amount of energy will be with you. Getting my point? If let's suppose if you are not stable, if atoms are not stable, if molecules are not stable, it means they are having high energy. There will be high energy in case of not stable. If they are stable, it means they are having low energy. Getting my point? Clear here? Am I clear, everyone? Pranav, please turn on your camera. This is not good at all. How many times I have to speak the same thing? Yes. Now, the principle of attaining maximum 8 electron in the valence shell of atoms is called octet rule. You might have learned this octet rule in your 9th standard, right? What is this octet rule? Let's suppose if I am drawing chlorine, let's suppose I am drawing fluorine, right? So how many electrons are there in the outermost orbit of the fluorine? 2, 2, 4, 6, and 1, 7. Yes or no, guys? Please tell me. How many valence electrons are there in case of fluorine? 7. Yes or no? So it needs what? 1 electron to get the configuration of noble gas. Yes or no? Please tell me. If I will take example of sodium. So sodium will have to give one electron. In case of fluorine, we were seeing what? It needs 1 electron to complete its octet, right? But in case of sodium, it will have to give one electron, so that to get the electronic configuration of noble gas, that will be neon. Yes or no? Am I correct here or not? Please tell me, guys. So sodium will be giving what? One electron. Outermost electron is what? One. And if it will be giving one electron, then it will become what? It will become stable, and it will attain the noble gas configuration. Yes. So why do atoms combine? Are you clear with this, everyone? The tendency to urge of atoms of various elements to attain a stable configuration of 8 electrons in their valence shell is the cause of chemical combination. So what is the cause of chemical combination? What is the need of what is the need of this chemical combination? Got my point, everyone? Fine, everyone? Any problem? Ashwin, Karthik? Yes. So why the need of chemical combination? So many things I have to teach in today's class. So please be concentrated in class, because if there are more topics, then I have to speed up myself. But I am not able to speed up myself because a new topic is there, and I want to make you understand each and everything in class only. That's why I'm not speeding myself. So guys, yes, Ashwin, Karthik, can you please tell me what is this? Why there is a need of chemical combination? Or why do atoms combine? Can you please tell me?
Sir, to become stable and
yes,
to acquire more energy.
To acquire more energy. If they are having more energy, then how they will be stable? I have told you in the class.
Less energy, sir.
Less energy. To acquire less energy, or to get themselves stable? To acquire the stability?
Both, sir.
Yes.
So due to minimum energy, there will be more stability.
Yes, very good. Okay, fine. Now, coming to the next slide, guys. So now I'm going to show you some Lewis dot structure, right? Or Lewis symbol, or electron dot symbol, right? Getting my point? So if I be drawing about the lithium, or beryllium, or boron, let's suppose, or aluminum, right? Or let's suppose if I'm taking chlorine. So will you be able to draw the Lewis dot? Lewis dot means what? Whatever be the valence electron that you have to draw with dot, right? Beryllium, if in case of beryllium, so hydrogen, helium, lithium, hydrogen, helium, lithium, and beryllium, right? So what we will be saying about the beryllium? How many electrons are there in the outermost? How many electrons are there? Can you please say me? 2. So can we write like this? Yes or no? If I will be talking about boron, then we can draw like this. If I will be talking about carbon, you can say right, carbon. We can draw like this or not? Please tell me, guys. So outermost electron is what? In case of beryllium, there is two outermost electron. In case of boron, there is 3 outermost electron. In case of carbon, there is 4 outermost electron. In case of nitrogen, if I will be taking nitrogen, what is the number of outermost electron in nitrogen? 5, guys. As I'm taking like this, so there are 5 outermost electron in case of nitrogen. So can we draw like this or not? Please tell me. In case of chlorine, do you remember I have tried to make you understand in periodic classification of element, the electronic configuration of this chlorine is what? 1s2, 2s2, 2p6, and then 3s2, 3p6, so 3p5. Getting my point? Chlorine is having what? 3p5. So there are 5, we can say 5 outermost electron is there. Yes or no? How many electrons? Sorry, not 5. 7 electrons will be there in. Yes, very good. 7 electrons will be there in the outermost cell. Yes or no, guys? Please tell me. How many electrons will be there in the outermost cell? 7 electron will be there or not? Please tell me. Yes. So it requires 1 electron to get itself more stable. That it will attain the stability of what? It will attain the stability of noble gas configuration. Getting my point, everyone? Fine for each and everyone. So according to Lewis notations, the symbol of the element represents the whole of the atom except the valence electron, right? That is nucleus and the electron in the inner energy cell. The valence electrons are represented by the placing dot, right? Or cross sometimes around the symbol. For example, the Lewis symbol for the atoms of second period are, this is second period. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, this is for third period. Getting my point, everyone? So will you able to draw the Lewis dot structure if I will be saying you? Yes or no? Please tell me. Okay. So what is the significance of this Lewis symbol? Can you please answer this question? Can you say me what is the significance of this? So what is the significance? It will tell you what is the number of outermost electron. Yes. And it will also show you that how much electrons you will add or how much electrons it will remove, so that you will get a stable compound or stability of the element. Yes or no? Fine, everyone? Yes or no, guys? Are you comfortable, everyone? Maurice, comfortable? Yes, very good. No. So we have that. Just if, let's suppose if I'm saying chlorine, so it will require what? One electron. Either you can take one electron, or you can do what? 8 minus number of that outermost electron. You will be getting the valence, that number of electron will be required. That number of electron will be required to get the noble gas configuration. Yes or no? Got my point, everyone? No. If I will be saying you write Lewis dot symbol for the following atoms and ions, I am giving you only 1 minute. Those who will be doing in 1 minute, then it's fine. Otherwise, I will have to move. So you have to, if let's suppose 5 questions I have given, so do only 1 and 2. That is O and Mg plus 2. Those who will be doing first, that is really very good. Your time starts now. Do fast. 7:55. It's in 7:56. You have to do the question. Those who will be showing in camera, and so I will be taking their name, and excellent student of the class will be given to her or him today. Educator of the class, excellent student of the class. These are some awards that I used to give in the class, right? Educator of the class. In the last class, there were 2 educators of the class. Nilambri and Bhuwana was there. Okay, we will see. How you are doing, that we will be seeing. Anyone who has done this? Anyone who has done this? If you have done, please show me, because it's already 7:56. No one has done. Nilamri, Anil Dev, Atachaya, Kaniska, Buana, yes, done. Please show me. MG, you have done 2, Atachaya. Okay. Anil Dev, how you have made? Nilamri, actually your camera is not much clear. Yes, okay, fine. Yes, Anil Dev, most of the students has done for oxygen, it is correct. Okay, I have seen, guys. So come here. For oxygen, it is correct, right? For magnesium, what will be that? 2, 2, 4, 4 plus 2, 6 plus 2, 8, right? So it will attain the electronic configuration of what? It will attain the electronic configuration of what? Neon, yes or no? And plus 2 charge will be there. Getting my point? So if I am saying Mg plus 2, so it will attain the electronic configuration of what? It will attain the electronic configuration of neon if there is plus 2 charges there. Getting my point, everyone? So will you be able to draw the rest of the question? Guys, have a snapshot of this and try this question at your home. Have a snap, because I have given so many questions in this today's slide, because I know that the difficulty level of this today's class. If I will have to draw this, then what will be the answer for this? O2 minus, it means what? It has also attained the electronic configuration of what? Neon? Yes or no, guys? Please tell me. O2 minus. So Ne and all the electrons that you have to give there, and -2 charge will be also there. Yes or no? Yes, please tell me. Everyone comfortable? What do you say? Are you comfortable? Comfortable, guys? Okay. So now you can see here that we have seen here the answers as well. Fine, everyone? Okay. Now, next. Write Lewis dot structure, Lewis dot symbol for the following atoms and ions. So will you be able to draw the Lewis dot structure for S and S2 minus? S is what? Old style. S means what? Sulfur. Yes or no, guys? For oxygen, it is what? There are how many electrons are there in the outermost? 6. Yes or no, guys? Please tell me. 6. So for S2 minus, so what will be that? Please tell me. S2 minus, how you will be drawing this? Yes, very good, very good, very good. So accordingly you have to draw for what? Al and Al plus 3. Will you be able to do or not? Please tell me. Will you be able to do? Please tell me, guys. Al and Al plus 3. What do you say for this? I hope now you are able to now I hope you are comfortable for doing these questions or not. Please tell me. Comfortable, everyone? So see the answer. For sulfur, because see, sulfur, oxygen, sulfur, selenium. These are coming in one line only, in one group only. Yes or no? Just after oxygen, sulfur will be there. Just after sulfur, selenium will be there. And after that, what will be the element? Anyone remember? Anyone who remembers this? No? Tellurium. And then after polonium. Getting my point? So outermost electron will be remain same. Yes or no, guys? Please tell me. For sulfur, that is what? 6 electron that I have drawn. For oxygen, that will be remain for 6. And even for S2 minus, it means what? 8 electron will be there and -2 charge will be also there. Getting my point, everyone? Clear, everyone? So will you be able to Al? So Al is what? Group 13 element? Yes or no? Please tell me. Group 13 or 14? See, just after boron, aluminum is coming, guys. Just after, just down. If you will go in the like from top to bottom, boron will be coming first in group number 13, and aluminum will be coming after, just after that. Yes or no, guys? You have to remember the periodic table. Periodic table is the key for for chemistry. That is very important. If you are not knowing the periodic table, there will be lot many problems will be coming in your path. Getting my point, everyone? Is it fine for you? Any problem till now? Any problem till now? No problem? Okay, fine. Good. So I hope you will be able to do this question. Even you can take the snapshot of all these things, or either you can download the PPT and you can do at your home, because in this PPT I have tried I have even given the question as well as answer as well, because these things needs to be practiced at your home as well. If you will not practice, you will forget. Getting my point? Okay. Draw the Lewis dot symbol for the following elements. Magnesium. Will you be able to do or not? Magnesium. You have to remember the first atomic number of magnesium, Mg. It is coming at what number? 12 number. Chlorine, Cl. Chlorine is coming at what number? 17 number. So one dot will be there. Yes or no, guys? Please tell me. Xenon. So xenon will be coming at what number? Helium, neon, argon, krypton, and xenon. So there will be 0 electron in the outermost. This is what? Inert gas. Inert gas, guys. So 0 electron will be in the outermost. Yes or no? Please tell me. Boron. I hope everybody is knowing boron. Phosphorus in the nitrogen group. In the nitrogen group, phosphorus is coming. Boron is coming in what group? Boron. That is B. Group number 13. Very good. Silicon. Just after carbon, silicon will be coming. So group number 14. So outermost electron will be what? 4. So you can see here, guys. Magnesium, phosphorus, chlorine 7, hydrogen 3. It is what? Xenon was there, right? Xenon, right? So xenon there will be 0, right? So there might be some problem in this. Silicon you have seen here. Sulfur you have seen here, right? So now. So will you be able to do this question? Draw the Lewis dot symbol for the element of the third period of the periodic table. In the third period, what elements are coming? Sodium, magnesium, aluminum. Then after phosphorus, sulfur, then chlorine, sodium, magnesium, aluminum, phosphorus, sulfur, chlorine, argon. Yes or no? 2, 4, 6, 7. Where is 1 electron? Sodium, magnesium. Yes, silicon will be also there. Aluminum, then silicon, then phosphorus, then sulfur, then chlorine, then argon, right? So will you be able to draw the Lewis dot structure for this this third period? Guys, will you be able to do or not? Sodium, Na plus. So 1 electron will be in the outermost, 2 electron in the outermost, 3 electron in the outermost, and after that carbon will be there. Sorry, silicon will be there. 4 electron in the outermost. Phosphorus, how many electrons will be there in the outermost? What do you say? Phosphorus. See here. Although we have done this question, guys. Again, sulfur. How many electrons will be there? We have done this for this question. Chlorine also. Argon also. Got my point, everyone? So try to do this question at your home now. Now, what we are going to see. Let's suppose if I am talking about sodium, magnesium, aluminum in the third period. So what is the outermost electronic configuration, right? Sodium. If I will be talking about sodium, 1s2, 2s2, 2p6, right? Then 3s1. Yes or no, guys? Please tell me. For sodium, can we write like this? 1s2, 2s2, 2p6, 3s1. Getting my point, everyone? And if Na plus is there, then 1s2, 2s2, and 2p6, right? So it will attain the noble gas configuration or not? Please tell me, guys. It will attain the noble gas configuration. Fine, everyone. Yes or no? Please tell me. So that we have done here. In case of magnesium, so it will be what? There will be 2 dot. Why 2 dot? When it will be added like 2 electron, the outermost, see, 1s2, 2s2, 2p6, and 3s2, right? If 2 electron, if there is what? If two electrons are there in the outermost, so 2 dot will be there, right? Getting my point, everyone? And if it will be losing 2 electron, then there will be the noble gas configuration will be attained. Fine, everyone. Any problem till now? Till now, anyone is having any problem? No? Okay. So let's suppose if I'm saying about the oxygen is having how many electrons in the outermost? 6 electron. So it will have to do, it will have to take 2 electron. It means there will be outermost 8 electron when it will take 2 electron. It means 2 minus will be there. In case of fluorine, so if 7 electrons are there, right? So it will take 1 electron. So it will become what? F minus. So the total number of electrons now it will be what? 8, but minus charge will be there. Fine, everyone. Is there any problem till now? Is there any problem till now, guys? Anyone is having any problem till now? No? Okay. Now, we will be going to see about the Kossel rule, right? We will be going to see about the Kossel rule. Till now, is there any problem to anyone? If I will go to ask to draw the electronic dot structure or Lewis dot structure of any element, so will you be able to draw or not? Maurice, what do you say? Will you be able to draw? Nilambri, Aswin, Karthik, Ashwin, are you looking somewhere else or what? Any game is there? Video game. In my childhood, I used to play, video game. Sometimes my teachers came in class and they took the video game and they are not returning, right? So what do you say? So guys, during the live class, you don't have to play, right? You have to concentrate here. Okay, fine. Come here. So we'll be looking about the Kossel rule, right? In relation to chemical bonding, Kossel drew attention to the following fact of the periodic table, right? In the periodic table, the highly electronegative. So who will be telling me what are the highly electronegative elements? Highly electronegative elements are placed in the S block, D block, P block, F block. Where? Vana will be telling me the answer of this question. Highly electronegative elements are present in S block, P block, D block, F block. What do you say? Vana, highly electronegative elements are present where? No answer. Guys, in P block, fluorine is the highest electronegative element. Fluorine is having electronegativity of what? 4. What do you say? Do you remember, guys? I have tried to make you understand the periodic classification of elements as well. Fluorine is having the highest electronegativity of 4. Yes or no? What do you say? Yes, P block. Oh, so many answers are coming here also. Yes, P block. Nilambri, Anil Dev, Ashwin Karthik. Ashwin Karthik, no sir. What? No sir. Okay, no problem. It means no. Okay, got it. So in the periodic table, the highly electronegative halogens are placed in the right hand and highly positive see guys, highly positive, or we can say what? Positive or electropositive. Electropositive, right? Electropositive. So electropositives are present in S block. You can say in the left hand side of the periodic table. Although electropositives are there in the D block as well, but highly electropositive elements are present in S block. Yes or no? What do you say? Like Na plus, Mg plus 2, right? So elements those are present in S block are the highly electropositive element, and the elements those are present in the extreme left, extreme right, you can say fluorine, chlorine, bromine. These are what? They are highly electronegative elements, right? So yes. So alkali metals, everyone is knowing what is this alkali metals? There are 2 metals. One is alkali metals and second one is alkaline earth metals. I have told you in the periodic classification of elements. So first group elements are called as what? Alkali metals. Everyone, is it fine for you guys? And the second group elements, first group elements are called alkali metals, and second group elements are called what? Alkaline earth metals. Alkaline earth metals. Fine everyone? Okay. So highly electropositive metals are present on the extreme left. These 2 families are separated by noble gases. They are having the separation of noble gases, right? Halogen gain an electron to form a negative ion, and while alkali metals lose an electron to form a positive ion. Getting my point? Halogens like F minus, it will gain 1 electron. Sodium, electropositive, plus charge, it will lose 1 electron to attain what? Noble gas configuration. If it will gain 1 electron, so it will become noble gas configuration. Yes or no, guys? There is a rule of what? Give and take. If it will give, so it will attain electronic noble gas configuration. Even if fluorine will take, then it will become a noble gas configuration. Yes or no? Please tell me. So fluorine, after taking attained the electronic configuration of noble gases, while sodium, it will remove 1 electron or it will lose 1 electron to attain the electronic configuration of noble gases. Got my point, everyone? Is it fine for everyone? No. Halogens gain an electron to form halogens gain an electron to form negative ion, while alkali metals lose an electron to form positive ion, right? Therefore, these ions are formed by the gain or lose of electrons by their respective atoms. Everyone is clear? How this ions will be formed? After gaining or losing of electrons? Yes or no, guys? How these ions will be formed? After gaining or losing of electrons? Everyone? What do you say? Okay, fine. Good, guys. Now, see here. The negative and positive ions so formed attain stable noble gas electronic configuration. The noble gases, with exception of helium, which has duplet of electrons, have a stable outer electronic configuration of 8 that is octet NS2 NP6. What do you say here? The negative and positive ions so formed attains a stable noble gas electronic configuration, right? Stable noble gas electronic configuration, right? The noble gases, with the exceptions of helium, which is a duplet of electrons, have stable outer electronic configuration of 8, that is octet, that is NS2 NP6. So in case of helium, neon, argon, krypton, xenon, see, helium is having duplet, right? Helium is having what? Duplet. This will be what? NS2 only. But in this case, NS2 NP6, this is what? Octet. So getting my point, what is the difference between the duplet and octet? Guys, one word that is new for you, that is duplet. And what is that? Next word is octet. Octet you might have heard earlier also, but duplet you might have not heard, right? Duplet means what? To attaining the electronic configuration of helium. Getting my point? Octet means having the electronic configuration of noble gases, that is neon, argon, krypton, xenon, radon, right? Fine, everyone. Till now, is there any problem? So that we are seeing that how the Kossel rules are varying, right? Now, this is the basis for the formation of chemical bond. The atoms can also acquire noble gas configuration by sharing with the other atoms. Therefore, there are two main types of bond. These are ionic bond and covalent bond. That I have started the class with this only. So what is this ionic bond or what is this covalent bond? So I have told you about the ionic bond. If anyone is having a capacity to give everything, like let's suppose if you are having 10,000 rupees in your pocket. So if you are donating 10,000 rupees to any church or any mandir or any masjid, so it means that you are having the capacity to donate everything, right? So there will be a strong bond will be formed, and that bond is known as ionic bond. And if they are sharing of lunch or with your schoolmate or with your friends, that will be there will be a formation of covalent bond. So let's see about the ionic bond. So see guys, ionic bond, or it is also called as electrovalent bond. So ionic bonds are also called as electrovalent bond. Getting my point, everyone? So ionic bond will be also called as electrovalent bond. Clear here? Now see here. When a bond is formed by transference of one or more valence electrons of one atom to the other atom so as to complete their outermost octet and acquire stable nearest noble gas configuration, the bond is called electrovalent bond or ionic bond. So what is this ionic bond? If there will be a transfer of one electron of same atom, or there will be a transfer of more than one electron to attain the nearest noble gas configuration, then that will be called as ionic bond. Yes or no? Everyone is clear with this? Is there any problem with anyone? No? SB has not joined today. And where is Kaniska? Yes, Kaniska is there. Yes. Yes, fine. Vana, you are not showing, only your bag is there behind you. Okay, you are there. So how's your biology going on? In which chapter you are in?
Excuse me, sir, am I audible?
Yes, you are audible. In which chapter you are
In my school, they are going with cell structure.
in? It means chapter 3rd and chapter 4th has also been completed.
Sir,
Chapter 3rd and chapter 4th.
1 minute, sir. I can't hear you. I will check what the problem.
Okay. Fix the problem first.
Yes, sir. No?
So chapter 3rd and 4th has also been completed.
Yes, sir.
Okay. Then sponges are the examples of which phylum?
Porifera.
Porifera. Very good. And there are some, water.
Vascular.
Yes. So what is the use of that?
It is used to transport food from the part.
Okay. What are slime molds?
Slime molds are from that's producing some disease.
Atomiceous earth is also there in your NCRT. What is the atomiceous earth? Diatomiceous earth.
Diatomaceous earth is formed due to the
Deposition of.
no, sir. It is formed to longer decomposition of
That is deposition of.
chrysophytes. So we call it diatomaceous earth.
Okay, very good. Yes, you are learning very good in biology also. Sometimes I will keep myself asking like that also. So guys,
Okay.
fine.
Fine.
So the question was relevant from your NCRT only.
Yes, sir.
Guys, I have gone through that book so many times, and I know it in and out of that book. That's why I'm able to ask you that type of question. And even questions are repeating in NEET examination as well, right? Okay, fine. So come to that point, because actually from last 45 minutes I was continuously teaching you the chemistry. You might be bored. That's why I have asked this question from Bhavana, so that to get some relax, right? So you are concentrating in this class. This is really very good, because some answers are also coming from your side. Whenever I am going to asking any question that you are giving, this is really very important for the class, that you are concentrating on class, right? So come here now. So how the ionic bonds are formed, that you have seen, right? Getting my point? So guys, in this also there will be a formation of charge, yes or no? There will be a formation of charge, either plus or minus. There will be a formation of charge, yes or no? What do you say? So if there will be extra electron will be there, so that will be removed, and that if there will be a plus charge is that, it means that there is, what it indicates, it will lose one electron to attain the electronic configuration. Getting my point? If there will be a minus charge is there, it means it will receive one electron to attain the electronic configuration of noble gas. So see here how the ionic bonds are formed, how the complete transfer of electrons are there. So if I am taking magnesium oxide, right? Magnesium oxide, right? So how many outermost electrons are there in case of magnesium? What do you say? It will have to lose two electrons, yes or no? Earlier, the electronic configuration of this magnesium is what? 1s2, 2s2, 2p6, and 3s2. What do you say? Is it fine? But this magnesium will have to attain the electronic configuration of its nearest noble gas. So near this magnesium, what is the electronic configuration? That is the noble gas is neon. Very good, Anil Dev. So neon. So the atomic number is 10, right? So it will have to lose two electrons, yes or no? And yes?
Break lega.
Yes? Yes, Bhavana? Want to eat bread?
No, sir. I was talking with my mother.
Okay, no problem. Okay. If you want to eat bread, then you will have to distribute to each and everyone in this class as well, right? Getting my point? Okay, now see here. So see, magnesium as outermost electron is what? 2. So it will have to lose 2 electron to attend the outer that is noble gas configuration. So it will give to whom? It will give to oxygen, right? So oxygen is there. Oxygen is ready to accept 2 electron here. Like oxygen is just looking into the magnesium when he will give me his 2 electron. Getting my point? Once this 2 electron will be removed from here, oxygen will just catch this 2 electron and will make a new bond, and that bond will be known as the ionic bond. Getting my point, guys? So oxygen is just looking into the magnesium when you will lose this 2 electron. When magnesium will lose, oxygen will just catch and will say, thank you magnesium, You have given me 2 electrons. Now we can form a new bond, and that bond will be really a strong bond between us, and that bond will be known as ionic bond. Got my point, everyone? Okay. Now see here. So what will be there? The outermost electron will be now 2, and 2 minus charge will be there. So the compound that will be formed will be known as what? MgO. Yes or no, guys? Please tell me. MgO, yes. So in this way, we can also form NaCl. Will you be able to form NaCl? Or MgBr? Will you be able to form MgBr? NaCl. In case of NaCl, let's suppose I'm taking NaCl. Yes, I'm taking NaCl. So first of all, I will be writing the outermost electronic configuration of this sodium. So it will be what? 1s2, 2s2, 2p6, and 3s1, right? Fine, guys. Outermost electron, that is 1 electron is there, right? It will combine with what? Cl. So Cl is having what? Outermost 7 electrons. Yes or no, guys? Please tell me. 7 electrons. And the outermost electronic configuration is what? 1s2, 2s2, 2p6, 3s2, and 3p5. What do you say? Is it fine? So now this electron will be transferred to this chlorine, and chlorine is looking into the sodium. Yes, sodium. Please give me your 1 electron. Once you will give me your electron, I will be really very thankful for you throughout my whole life. I will be more thankful for you throughout the life if you will give me your 1 extra electron. As there is no use of your electron, so why you are keeping this electron? This extra money, please give me, and I will form a bond with you throughout the whole life, right? So there will be a formation of what? Na plus and Cl minus. Getting my point, guys? So there is a charge. If there will be a charge, it means there is an ionic bond is there, and if there is an ionic bond is there, so it means what? There is a strong bond. There is a strong bond. Getting my point, everyone? Are you happy with the formation of this relation between the sodium and chlorine? If sodium will give its one electron, it will form a strong bond with chlorine, and chlorine, who is eagerly waiting to receive his one electron from the sodium. So if this happens, there will be a strong bond will form between sodium and chlorine. Getting my point, everyone? So will you be able to form this kind of bond from your side or not? Is it fine for you, everyone? Is it clear now how these ionic bonds are formed? Now, after this, we will be also looking how the covalent bonds are formed, right? How the covalent bonds are formed, that we will be also looking into that. Okay, fine. So guys, there are a few more examples are there. Magnesium bromides are there, and sodium sulfide is there. Calcium sulfide is there. So due to the limitation of the time, I'm not explaining that. You will have to see that, because I used to give more examples in the PPT, so that whenever you are referring that, you will be able to understand the concepts. I have explained these two. This is enough for you. Everything, if I will be going to explain, then it will take more time, right? Now, formation of ionic bond. The formation of ionic bond compounds are primarily depend upon the ease of formation of positive and negative ions from the respective neutral atoms. So neutral atom is what? Sodium and chlorine, right? Neutral atom. So there will be a development of positive charge and negative charge, right? The arrangement of positive and negative ions in the solid, this is also called the lattice of crystalline compounds. Fine, everyone? So there will be a lattice of crystalline compounds. Now, Kossel-Lewis, on which we will be seeing factors on which the formation of ionic bonds depends, right? What are the factors that we will be seeing here? First one is low ionization enthalpy. Second one is what? High electron gain enthalpy. Third one is what? High lattice enthalpies. And these three things are that we have to see. What is this? First one is what? Low ionization enthalpy. Do you know, everyone? I hope everyone is knowing now. Low ionization enthalpy. That is what? IE. You have to just remember these factors of the bond formation. That is what? First one is what? IE. Low IE. Second one is what? High electron gain enthalpy. If low ionization enthalpy will be there, so there will be high electron gain enthalpy will be there. And third one is what? High lattice enthalpies will be there. Getting my point, everyone? See, these the ease with which an atom can lose electron depend upon its ionization enthalpies. You have seen in the case of in periodic table also that what is IE1 and IE2, IE3, right? So it is easier to remove one electron from the outermost, but if you will go to remove the second electron, it will be more difficult to remove the second electron. Getting my point, everyone? So ionization enthalpies. So the factors on which this ionic bond will be dependent will be what? Ionization enthalpy, electron gain enthalpy, and third thing is what? Third thing, what do you say? Low ionization enthalpy, high electron gain enthalpies, and third thing is what? Lattice enthalpy. These things are important, right? Okay, important points on the Kossel rule. The sum up the conditions for stable ionic bonding are: the ionization enthalpy of atom forming the cation should be low. The electron gain enthalpy of atom forming the anion should be highly negative, and lattice enthalpy should be high. These three things that you have to keep in your mind. Getting my point, everyone? Now, okay, guys. Now it's 8:30, so you can take a break of 5 to 7 minutes. Then we will be coming to the point about the lattice enthalpy, and then we will be seeing after that we will be seeing about the covalent bond, right? Everyone is fine with this? Okay, guys. You can take your break of 5 to 7 minutes. Then we will be back. Hello everyone, are you there? Yes guys, now look into the covalent bond. See guys, according to Lewis-Langmuir theory, atoms can combine by sharing of electrons. So I have told you in the very beginning of the class. So atoms can combine, two people can combine by sharing their electrons, right? By sharing their lunchbox, right? So in this way here, there will be a formation of what? Covalent bond will be there. What will be formed? Covalent bond will be formed. Getting my point, everyone? So now, see here. If I will be taking hydrogen, right? So hydrogen will combine with this hydrogen. You know, what is the number of outermost electron in hydrogen? I hope you all are knowing. One outermost electron is there in case of hydrogen. And this hydrogen also will be having one outermost electron, right? So this hydrogen will share this electron with this hydrogen, and this hydrogen will also share its one electron to this hydrogen, right? So see guys, how this will form, right? How this will form, you can see here, there will be a sharing of electron will be there. So single bond will be formed. Hydrogen alone will not be existing, right? Hydrogen, until unless it will not form H2. So H2 will be formed how? How H2 will be formed? So by sharing of outermost electron of this hydrogen and this hydrogen. So there will be a formation of H bonding. So it will be what? H and H. Single bond will be formed. Getting my point? Now, in case of 2H and oxygen, if there is 2H is there, right? So you can also say that H2O. H2O, right? Getting my point? So you know how many outermost outermost electron of this hydrogen and outermost electron of this hydrogen. See guys, you have to draw this, right? H, one electron, and again, what about this oxygen? What do you say? I am drawing the electrons of this oxygen with cross, right? Try to understand here. How many outermost electrons are there with this oxygen? 6. What do you say? 6. Guys, 6. So now, this one and this one, right? Now again for hydrogen, right? One electron is there. What do you say? Are you comfortable with this? So see how this bond will be formed. This will be formed like this. This will be formed like this. Yes or no guys? Please tell me. What do you say? And again, this will be formed like this. Getting my point, everyone? Getting my point? Yes, yes, yes or no? Please tell me, guys. So how this bond has been formed? Similarly, nitrogen has 5 electrons. If I will have to draw N2 molecules, how this will be formed? N2 molecules will be formed. See, nitrogen, how many electrons are there in the outermost? 5 electrons will be there. Yes or no, guys? So see, 2 electrons here I am drawing, and 3 electrons here, right? Again, 3 electrons of this nitrogen I am drawing with cross marks, right? Getting my point? And this will be shared, right? This will be shared. So triple bond will be formed between nitrogen and nitrogen. Guys, 2 electrons are required to form a single bond. Yes or no? What do you say? 2 electrons, this is 1 electron, this is 1 electron, another electron. 2 electrons are required to form a single bond. So 4 electrons, right? 4 electrons will be required to form a double bond, and 6 electrons will be required to form a triple bond. Getting my point, everyone? Everything is clear now? No. If in case of this, see here, NH3, if you have to form a bond of covalent bond for ammonia, so how you can make? So 3H there, it means what? H 3 will be there, 3 electron will be of H, and nitrogen is sharing how many electrons? Nitrogen is having how many outermost electrons? 5. Guys, are you comfortable with this? Yes or no? Should I have to draw this, or you are knowing now? Will you able to draw? Will you able to draw or not? Please tell me. Now, I am not explaining this. I am going to explain this CCl4. This is what carbon tetrachloride. Carbon tetrachloride, CCl4. See guys, if you will see in in molecular structure, if you will be seeing, it will be like this, CCl4, right? So what do you see here? Carbon, and for every bond you have to do what? You have to draw one, for every bond you have to draw 2 electrons, right? So no need to worry here. For this carbon 1 electron, for this chlorine 1 electron will be there, right? What do you say? For this carbon 1 electron will be there, and for this chlorine 1 electron will be there. What do you say, guys? Please tell me. Again, for this carbon 1 electron will be there, and 1 electron for this chlorine, 1 electron for this carbon, and 1 electron for this chlorine. One electron will be shared. Although this chlorine is also having 7 electrons, right, in outermost, right? But it needs how many electrons? It needs 1 electron. Yes, to get itself to get the octet completed. Yes or no? What do you say? So what do you say? You can see here chlorine 1, 2, 3, 4, 5, 6, 7, 8. 7 electron of this chlorine and 1 electron of this nitrogen. They have shared with each other to get their self completed. Getting my point? Yes or no, everyone? Now again with this chlorine, 2 to 4 to 6 and to 8. 1 electron of this C. Here there is a sharing of nitrogen and chlorine. There is a sharing of electron of nitrogen and chlorine. Are you comfortable, guys? Please tell me. See, total number of electrons of nitrogen is what? Outermost 5, 2. See, you can see here 2 electrons is here, 2 electrons is here. You can see here, guys, if you will count this, you will get that what octet has been completed. Getting my point, everyone? Clear? It is clear to each and everyone? Yes or no, guys? Please tell me. It is clear to each and everyone? See, guys, by mistake here there is N has been formed, right? It should be C. Here it should be what? C. CCl4 is there, right? Not NCl4. So 1 electrons of carbon is having how much outermost electron? 4. So 1 electron for carbon, and outermost electron 1 will be shared with this chlorine, right? So there will be what? CCl4 will be bond. So you can see here 2, 4, 6, 8. 8 electron for this box, 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 and even for this inner one there will be 8 electron will be there. Getting my point? So octet has been completed or not? Please tell me. So this octet has been completed how? By sharing of electrons. Yes or no, guys? Please tell me. Fine, everyone? Now, see here, I have told you that if there will be 2 electrons, so single bond. If there will be 4 electron, then double bond. If there will be 6 electron, then there will be triple bond will be formed. Fine, everyone? Now, if you have to draw the electronic bonds of covalent bonds, so how you will be drawing oxygen? See how many electrons are there in the outermost orbit of the oxygen? 6. Yes or no? Please tell me. So you can draw like this, guys. So this will be shared like this. Yes or no? So O double bond O. 4 electrons has been shared, guys. So double bond will be shared. So there will be a double bond will be formed. What do you say? Fine, everyone. Please say me. Is there any confusion till now? No? Okay. See here. So if you have to draw CO2, carbon dioxide, if you have to show in a bonded form, how you will be forming? So see, guys, carbon will be in between and oxygen will be in this side, right? So oxygen is having how many electrons in their outermost? 2, 2, and 2, 6, right? What do you say? So for the purpose of bonding, I am drawing this 2 here, right? In front of this carbon, right? 2. And again here 2, 4, and 6. Getting my point? And carbon is having how many electrons? Outermost electron is what? 4. So 4 electrons of this carbon. Now, how will the bond will form? What do you say? There will be a bonding between this. What do you say, guys? Please tell me. First, there will be a formation of this bond, and there will be a formation of this bond, right? What do you say? Actually, due to some, actually this has made my drawing is not much good, so that's why I have expelled from biology, right? So my drawing is not much good. So carbon, see, carbon will be in the center, and this 2 electron and this 2 electron of oxygen will be shared, right, guys? Like this, and again this oxygen and this 2 electrons of carbon will be shared. Yes or no? You can see here. So there will be a double bond will be formed between oxygen and carbon and oxygen. Getting my point? So O double bond C and C double bond O. This will be like this, right? Right, everyone? Getting my point? How this formed? Getting everyone? No problem. Okay. So this I have drawn earlier only, nitrogen and triple bond, and I have shown you earlier only. Getting my point? Everyone fine? Is there any problem? Guys, I have also speed up this class, but I hope you are understanding. Is there any problem? Here you will be facing problem. C2H4 is there, right? What is this C2? First of all, I have to teach you this C2. Is there any problem till now? Here, is there any problem? I hope this is comfortable. If I have although speed up myself, but this is comfortable to understand, right? These are the things that you can understand easily. But here you will be facing problem because this is carbon compound, so you will be facing some problems here. See. C2H4 is there. First of all, understand the carbon, and there is a relation between carbon and carbon, right? How we can draw this? C, 2C is there, right? And there are 4H, so we can draw like this, 4H, right? These are 4H. Yes or no, guys? Please tell me. So carbon still will have to form double bond to get their self completed. Octet should be completed. So there is a double bond. Yes. So it is like this only. There is H. There is H, there is H and H. Fine, everyone. Is there any problem till now? So you can see here, just here also it has been also formed, right? Now, can you draw the dots for this carbon, hydrogen, carbon, hydrogen? So you can see here, 1 dot for this hydrogen and 1 dot for this carbon. Getting my point, everyone? If you are not getting the C, I am drawing again. Carbon, I have to draw first 2 carbon. How many electrons are there for carbon? So this carbon 2 electron and 2 electrons. See, 2 electrons with this carbon and hydrogen is here, right? So and again hydrogen is here. So single dot I am showing for this hydrogen, right? But still, what do you say? There are two electrons are remained with this carbon, right? So that I am drawing with this. To make this bond with hydrogen, there must be 1 more electron should be there. So the 2 electron will be there, then only we can form a bond, right? So one bond for 1 electron for this carbon and 1 bond for this 1 electron for this carbon. So there will be a formation of bond like this, right? Getting my point, everyone? Fine now? Now again, come to this point, come for this carbon. How many electrons should be with this carbon? What do you say? How many electrons should be with this carbon? How many electrons should be with this carbon? Please write in the chat section. This carbon should have how many electrons? Carbon should have how many electrons? Outermost electron is what? Nobody is saying. 4? Yes, very good. So I am writing, see guys, I am writing this 2 electrons for here and 2 electrons I am drawing with C. This 1 electron and hydrogen, 1 electron of this hydrogen, right? Getting my point, everyone? Again, one electron for this carbon and 1 electron of this hydrogen. So it will be shared or not? Please tell me. It can be shared. Fine. Getting my point, guys, everyone? It is fine for you. Now see here, there is 4 electrons in between carbon and carbon. So it means what? 4 electron is there. So double bond can be formed or not? Please tell me. Everyone, it is clear to you. Please say me, is there any problem till now? So okay. So we can draw like this. We can draw like this. So are you able to understand now how this has been made? How this has been formed? So if you will look into the figure, so each and every carbon is now, you will be seeing that the octet has been completed with this carbon also, with this carbon also, and with this carbon also. If you will be seeing, the octet has been completed. So the particular compound is this only, right? Getting my point, everyone? You have to try at your home, then only you will be able to draw this structure, guys. Okay, now see here. Lewis structure and covalent bond. See, the main condition for writing the electron dot or Lewis structure of the covalent molecules are: each bond is formed a pair between the atoms. Each combining atom contributes one electron to the shared pair. That we have seen here. Each combining atom contributes one electron to the shared pair. Now, third is what? Both the combining atoms attain the stable outer shell noble gas. Both the combining atoms attain the stable outer shell noble gas configuration as a result of sharing of the electrons. In other words, octet, both the atoms get completed. So both the atoms will be having their octet completed. Now, so this we have seen already, guys. What do you say? This we have seen already. CCl4 we have seen already, right? Now, so this is the Lewis representation of O2. We have seen O3. This is the new one that you can draw at your home also. CO we can draw. Carbon, CO, right? Carbon is having how many? 4 electrons outermost, and this oxygen is having 6 electrons outermost. So there will be a structure like this. You can see here. Getting my point, everyone? See, actually what will be there? You can see here, this carbon and oxygen, how they have been settled down. You can see here. Getting my point, everyone? Fine. Now, so these things you can practice at your home now. We have seen so many structures. Now, we are coming to the next topic, that is formal charge, right? So see guys, formal charge. To the topic, what is this formal charge? In case of polyatomic ions, the net charge is possessed by the ions as a whole and not by the particular atoms. I will be teaching you how to find the formal charge of particular atom, right? Don't worry about this. Just see how I am teaching. Just see only, and then after that I will how we can do the question that will be that you can do, right? It is possible, however, to assign a formal charge on each atom. So we can assign a formal charge on each and every atom, right? The formal charge of an atom in a polyatomic ion or molecule is defined as the difference between the number of valence electron in an isolated or free atom and the number of electron assigned to that atom in the Lewis structure. How many free electrons are there? How many bonded electrons are there? So these will be defining the formal charge, and how that will be calculated. There is a formula. Try to learn this formula. If you are able to learn this formula, then well. Otherwise, I will be giving you one trick to find the answer of the question. What is the formula for formal charge on an atom in a Lewis structure? Total number of valence electrons, right? Total number of valence electron in free atoms. Total number of valence electron, V, right? Total number of bonding lone pair electrons, that is B, bonding, right? So total number of bond that you have to see. Total number of bonding shared electrons. Shared electrons means what? Dot, D. Getting my point, everyone? So what you have to see? V, L, and S. Getting my point, everyone? See, the formula is quite complex, right? You may write down or you may learn this formula, but now we will be going to do the question. The question I will make very simple for you. How we can do the question very simply, that I am going to do for you. It might be possible that it looks a difficult formula for you, but I will do the question, then it will be more easy for you. Getting my point? How to find the formal charge on each and every atom? The question is this, right? If let's suppose there's a compound, and how to find the formal charge on each and every atom. Try to see here. So these things that we have seen, Vc means formal charge on atom, V is total number of valence electron or in the free state, L is total number of electron present in the non-bonding lone pair, and S is total bond pair. But don't see on this what I'm saying. I'm giving you one compound first. See here. If I have to find the formal charge in this chlorine, if I have to find the formal charge in this chlorine and in this chlorine also. In this chlorine, let's suppose if I have to find the formal charge in this chlorine, what I have said you V, B, D, right? V, B, D. V is valence electron. How many valence electrons are there for this chlorine? What do you say? How many valence electrons are how many valence electrons for chlorine are? As you know well, 7, right? Minus. If this bonded with anyone, how many bonds are there? How many bonds are there? 1. So minus 1, right? And how many dots are there? Minus that. 2, 4, 6, right? 6. So formal charge on this chlorine will be what you know? 7 minus 1 minus 6, that will be what? 0. Is it easy or not? Please tell me. Let's suppose if I have to count on this carbon, the formal charge of this carbon, if I have to count, then how we can count the formal charge on this carbon? What do you say? First, write the outermost electron of this carbon. So outermost electron of carbon is what? Valence electron is what? 4. So write 4 first. Then minus B. B is what? Total number of bonds. So how many total number of bonds are there? Total number of bonds, what do you say? Bond 4. So minus 4, right? Now, how many electrons are there? How many dots are there? How many dots are there, guys? 4. So minus 4. So total answer is what? 4 cancel out. So minus 4. So the formal charge will be what? For this carbon will be what? Minus 4. Getting my point? Who is not understanding these things? Please tell me. If I will have to draw for this chlorine, this 2, how we can draw for this? So first, valence electron of this chlorine is what? 7. So I will be writing 7. Then B, bond is what? 1. So I will be writing 1, right? Dot is what? 2, 4, 6. So minus 6. So answer will be what? 0. Yes or no, guys? Please tell me. Yes or no? Everyone, it is comfortable for you or not? Please say me. Guys, when you were seeing the formula, it was quite difficult for you. Oh my God, what is this formula? But with the help of this VBD, V for Vinayak sir, B for bonding, and D for what? This, D for what? D for you can take anything, right? So V, valence bond, and D for what? Anything that you want to take. So VBD, with the help of this VBD, you can find any answer. Let's suppose if I have to find for this oxygen, then how you will be finding? This oxygen, number 1. Who will be saying the answer for this question? V for, I am asking with Kaniska will answer this question. Kaniska, please tell me what will the answer for this? What will be the formal charge on this oxygen? Formal charge on this oxygen?
The valence is 6. So 6 minus
6 minus
3 bonds are present.
3 bonds are present.
Minus
Yes.
2
2 dot is there. 2 dot are there. So 6 minus 3 minus 2. So the answer will be what? 1. Yes. So formal charge will be what? 1. Got my point, everyone? It is clear. If I will ask for this oxygen, who will be going to give me the answer for this? So you have to remember VBD only. VBD. What will be the answer for this? Oxygen 6, right? 6 minus B. B is what? B is 2. So 2. D is what? 4. So answer is what? 0. Got my point, everyone? So I hope it's very easy task for you to find the formal charge on any atom. Yes or no? It was looking really very difficult in the, even I am not knowing this formula, right? I used to solve by this method only, BBD, by this BBD. Getting my point, everyone? But if you want to remember for your examination, for 11th standard school examination, you can remember that formula, that will help you. But if you are solving the question of JE, then you can use this BBD, your answer will be solved. If you will be going to solve by the formula that is actual formula, then it may take some time. But by this method, in a second you can answer the question, right? Fine everyone. Is there any problem till here? No. Okay. Yes. We have discussed all these things. If I have to, yes. If I will be going to ask you this question, what we calculate the formal charge on Cl in SClO4? SClO4. How will you finding this? You have to find the formal charge on Cl. How you can find? Can anyone tell me? Can anyone tell me? Guys, please tell me. SClO4, and you have to find the formal charge on chlorine. It's one of the tough question, or you can say, it's not an easy question for you. Try to give the answer for this question. Anil Dev 3. Are you comfortable? Are you sure? Let's check the answer. Yes, very good answer that you have given, that is +3. So first draw the Lewis dot structure and then find the answer. Getting my point, guys? First draw the Lewis dot structure, then try to find the answer from there. Okay. So we have almost done almost everything here. One thing is that limitations of octet rule, right? That we will be seeing, and after this you can start your class assignment. Although octet rule is useful in a large number of cases, it has many exceptions also. Some important exceptions of octet rule are given, right? That is, for hydrogen molecule, it will be forming duplet, not octet, right? In incomplete octet of the central atom, like LiCl, BeH, BeCl, BH, BF, these are what? These are the exceptions that we have to see, right? Okay. And expanded octet of the central atom, what? There are many stable molecules which have more than 8 electrons in their valence shell. For example, PF and SF and 12, and that is, and IF has 14 electrons around the central atom. P and S and I respectively, so that you can see here. So here there is what we can see, that there is an expansion of this octet rule, right? So there are some limitations are also there, and there are some expansions are also there. So that we have seen in today's class.